Now it's on. Hey.
This one's not. There we go. All right. So, the Ventuz Real-Time Advantage. Real-Time Graphics Primer.
Don't steal my lines.
Sorry. Oh, okay. Hi, everybody. So Eric Ludacer. Eric has, again, I worked with Eric at Christie. You might have heard us bickering back and forth during several meals, back and forth about different things and, war stories and fun stories and memories and things like that. And it's been really interesting to follow Eric, even after my time at Christie. I ended up leaving a few years before Eric did, and just kind of seeing the transition and how things changed. It's one of the really interesting and cool things about being in this industry is you make amazing long-term friendships, and you get to see people kind of grow with you as you kind of go through life, and things evolve, and you kind of interweave in and out. And Eric's been one of those people that's kind of been in and out of my life over the last several years, and it's been really cool to be able to kind of make friends and keep them for long periods of time and be able to just pick right back off where you left off. So it's one of the really cool things. So Eric's now, working at a company called Ventuz. Ventuz, I'm sure he'll give you insight as to what Ventuz is and what Ventuz does, but they've been around again for quite a long time. The products that they've been creating is bar to none, like they are bleeding edge. They've got a lot of pretty amazing things inside of their tool set. One of the big things we've always talked about media servers being quote unquote real time, and they do process things in real time and can do things in real time, but this is truly a full real time application. So I'm going to hand it off to you on that note, and you can
Thank you very much.
Show us what you got.
As Jeffrey said, it is interesting. There's at least 2 other people in this room that I've worked with before. So it is a small world. We've said that multiple times. As mentioned, I now work for Ventuz. Just to give you a quick rundown of myself, I too studied as a lighting designer. Technically got sick of people telling me what my art, i.e. lighting design, should look like. So I chose to go the route of understanding and becoming a production electrician. How do things work? How does it go together? How do we move it from venue to venue? After graduating, I went on several Broadway tours nationally, internationally, until I ended up joining Cirque du Soleil, worked very briefly with Mark here, and then chose to move to Vegas and really delve into the Cirque world. I was the head of projections for The Beatles' Love by Cirque du Soleil in Las Vegas, and then I moved on and became the head of video, lighting, and special effects for the creation of Michael Jackson 1. Then I took a hard left turn and went to work for a little lady named Miss Britney Spears for about 2 years as her video director for her residency show, and then switched to the dark side and joined the manufacturing, where I joined Christie as part of the Pandora's Box team for North America. Recently left about 6 months ago and joined Ventuz Technology. So I have a media server background, and what I find interesting is, let me ask this question. How many people out here have experienced real-time graphics? Every single person should raise their hand because you've all played video games, right? Those are truly real-time generative graphics. Now let's talk about why those are needed. So real-time motion graphics are animated graphics that are being generated and rendered while they're also being delivered to the media devices, right? We've talked a lot about media servers. Typically, all of that content is pre-rendered. It's baked in. You're just playing it back. Real time is generating and rendering while also delivering to the external devices. So this means each graphics frame has to be rendered at extreme high speeds so the audience can perceive that they're moving fluidly and there's no dips, tears, anything like that noticeable, right? So taking as a reference a typical 60 frames per second cadence. That means that graphic frames must be rendered and output in 16.7 milliseconds, right? Per 60 frames. So that number gives you an indication of the complexity of the task that real-time graphics are doing. The system must be able to calculate complete frame, which is including transformations applied, graphic elements, materials, illumination, shadows, camera emulation, and a myriad of other graphic effects in less than 17 milliseconds. And It also has to be not so resource intensive that it can keep a steady performance for minutes, hours, or days, depending on the use case of the system, right? We won't talk too much and delve too much why or how we do this, but basically a lot of media servers, as Michael showed in his slide, use a combination of CPU and GPU. When you get into real-time graphics, you're more likely than not focused completely and totally on the GPU. That's why in a real-time graphics machine, you're going to be using a very high-end gaming type card to produce these graphics and these kind of subsets. Let's talk about why people are interested in real-time graphics and that sort of thing. In general, real-time graphics are used on projects where fast changes are needed because long rendering times and that sort of stuff. I think Kirsten spoke to that yesterday. Sometimes they've got to re-render and try to deliver 10 minutes, 5 minutes before an opening, where real-time graphic changes can be instantaneous. And you can choose to do them in any timing format that you want. In addition, most shows that are run on a media servers, pretty much everything you're seeing out here at Luma Festival is a linear based show. It goes from point A through points B and C all the way to point Z. When you're in real-time graphics, you're starting to get into non-linear capabilities and interactivity that can be on the fly and happen at a moment's notice. So these are all the real cases that we want to use. So I'm going to talk just a little bit more about that. And then I'll jump into real-time graphics. I'm going to do my real-time graphics display using Ventuz. It's not that's the only one out there. There are other products such as Notch and some other real-time generative effects engines that do exist. Obviously, I will just do most of it in Ventuz and talk about both the software and why we do this and what our feature sets and capabilities are. So let's talk a little bit about other reasons for real-time graphics. Unforeseeable events. If there's a change, we do a lot of work with Quince Imaging on the esports type stuff, League of Legends. And let's say at the last second, they're about to interview someone live on air and they decide at the last second, they're going to go interview someone else. Maybe you have to change the slide title that's going to pop up for that person when they're on air. If you don't have a pre-rendered slide title for that specific player, so let's say the main player has a horrible game, but the guy who's relatively unknown has an amazing game, they're going to want to interview that guy. You likely didn't make or pre-render a slide with his name and his country or whatever on it. Real-time graphics, you can actually just type those informations in, choose the logo, and send it to air almost instantaneously. But it doesn't only have to be for broadcast. That's where real-time graphics really are right now in the broadcast world, right? Everyone in here has watched ESPN or seen a sports ticker. Those are all real-time graphic stuff. But now we're making a push into live events, interactive art installations, and that sort of thing. So we can do interactivity just like I spoke about because we can handle easily touchscreen gestures or hand tracking or camera tracking. We can do full tracking to be able to do engine-to-engine integration. So Ventuz has an engine-to-engine integration with Unreal, right? We've all talked about how somewhat difficult Unreal is for people to learn and work in. Someone could easily give me an Unreal world and I can populate it with other items from Ventuz and still work them together as well and seamless as needed. Also, Ventuz has the capability to control other external components as well through TCP/IP, RS-232, whatever data streams we want. So we can integrate with other control systems, encoders, sensors, any type of that. But another of the main things that's really interesting about real-time graphics, and especially Ventuz, this is what Ventuz does, it's its bread and butter, is real-time data. Like, for example, at the Energy City that Court did, we could be monitoring, if there was a way for us to monitor how much electricity was being used in every single one of those houses on the model, we could take that data and present it visually on the model in real time. So you could be like, oh, that house, they just turned everything off, or that house just turned everything on. And we could show that in real time as it happens, if that's what we so chose to do. Also with real time, we can handle, of course, multiple outputs. We can do all of the things that a lot of media servers do. We can do big canvases, small canvases. But the big thing is all about last minute changes. So if we look at use case scenarios, and then we'll get into the software and talk about some stuff. If we look at use case, of course, broadcast sports. That's kind of where in the US, Fox Sports, ESPN Sports, I'll show you a video here with an on-air package in a bit from Major League Baseball. newsrooms for weather updates or news updates, as well as extended reality sets or green screen sets. We can do all of those kind of things. Game shows, right? Game shows are one of those unpredictable things in terms of the broadcast world that we need to be able to just basically have every path option to us available at a moment's notice, because hopefully they don't know how the game's going to play out, right? Never know. Channel branding, automation. In fixed installs, we can do high-end digital signage, and I'll show you examples of some of that. Of course, like I said, data visualization is big, especially when you get into like corporate events. How much money did we make this year? You want to be able to show that off digitally. Any type of physically controlled content, of course, minority report type stuff where you want to be able to move images or expand them, spin them around, that kind of thing. So with that, even to give you an example of real-time graphics, everybody did PowerPoint except for me. I made a very quick slide inside of Ventuz, hence the reason I'm able to do the lighting that you see going back and forth, the small turning of this image that's just slightly panning back and forth. But because this is real time, I have a simple web GUI on my machine. I can change this at a moment's notice to someone else. So you'll notice now it's for Mike Steinbrecher, who is our Director Global of Sales. I can also change the image if I didn't want the USITT graphic. Excuse me, it's very low res, but I could quickly switch it to a Ventuz graphic. I can pre-populate all of this stuff and either save them or presets, or if I had to at the last second, I could type in any type of text that I wanted to this line and make a change however I wanted to in real time. So let's say, let's go. So I could type that, and as soon as I hit enter or go away from it, you can now see it says, hello, everyone. So at the last minute, if they just change speakers, that kind of thing, it's all reliable. Now let's talk about what's really useful on this. I'm going to change scenes and go to something like, let's go to that. So here's a basic graph, right? I could be receiving this information either live, it could be from an encoder, it could be from a voting system, and I can change this on the fly. So I could say, I want that to be bigger. I need my bar height to be smaller. I need my base radius to be bigger, right? I don't like the color of the graph, so maybe I want the color of the graph to be pink. I can do all of this. Now, I'm doing these in very low res kind of just images to give you guys an understanding of what is capable. At the end, I will show you some scenes from shows we've done that show off its real feature set, but to give you an idea. Now, this is, again, I've got all of this. I've created my scene. In my scene, I can take, what's nice about real-time graphics is you can usually take in Notch or Ventuz. You can take the parameters of a scene that you want and unlock them. Basically means make them exposed, expose those values to be controlled by a lighting console or a web interface or something like Ventuz Director, which allows me to type in or choose a different aspect or a location. Maybe I've got a pip and I never know where it's going to go. I can choose up or left. And yes, you can do that very easily in a media server by keyframing all of those positions and then being able to jump around. But here it's as simple as, because I've exposed that XY value, I can move it anywhere I want by typing in numbers or making presets, kind of like what a lighting console already does with all of its presets. So there's a whole bunch of things we can do. Again, also I could change, if I really wanted, I could change text color. So all of these things are possible. Other things you can do, of course, when you get into real-time graphics is, let's go to angular gauge right here, right? So I have this silly little gauge. If I wanted to, I could type in a number, so 50, right? And because it's real-time graphics, I can put in that little bounce that you see of the needle. I could choose if that's there, if it's not there. I could also take all of this data and put it to an array of numbers. So I've been able to enter an array of numbers, and simply by hitting next, I can change those graphics in real time, sort of to whatever I want. Now, we're going to jump to one other thing that you could easily do. This is a quick little weather API I threw together last night. So this basically is actually using the web to go to openweather.org, and I'm doing an API call getting the name of a city, and I have an index up here where I can change whatever city I want to look at. So I can, let's go Hamburg, Hong Kong, New York City. You can see the icon also changes to relate to whatever it's receiving from this weather API. And because I'm making a weather call, I'm getting all this information. I can then parse out what is the information that I want to see, right? I'm using JSON here to parse out. I only want to know what is the temperature, what is the city, and what icon is your weather app showing. And then of course, you know, here we don't tend to use Celsius here in the States, so I can easily switch that to Fahrenheit with just the touch of a button. Now, Ventuz could also make this scene so I could have buttons right here that would go through those cities. So if this was a touch screen, I could touch them, or if I had an air scan, as mentioned before, I could make my presentation also my interactive surface to be used to display however I want. So I'm going to talk a little bit about here. Now we're going to do a couple things that is going to be different. So give me 1 second. I'm going to close some software and change up my computer so we can all have a look at this together. So let me just duplicate my displays. That way I'll see what you're seeing. And we are going to reopen Ventuz. So Ventuz is a software-only system. We don't get into the hardware side of things. For big clients, we'll help you spec software or do whatever you need to do. Again, Ventuz is very well versed and based in the GPU. So depending on what your CPU requirements are, we can handle those. And then of course, we recommend high-end gaming systems depending on what you're gonna do. So I'm gonna open up I've got all kinds of different projects here you can see. I am going to open up a project that we used originally for ISE 2022. Let's go for the main project. All right, and well, here, we'll just put it in full screen so we get some nice graphics here. All right, so you can see here, the things that we've done is basically made a really nice playlist. So how you were talking about how you had to go in and be able to adjust the show. In Ventuz, you work on things called pages, or scenes. You can then make a list of scenes. You can take those scenes into an Excel, and you can say, I want this scene to bring up this and play it for this long, and then go to the next scene, and you can adapt it just by typing in to an Excel spreadsheet in this case. Or it could be pulled from a JSON file, so corporate could download a new playlist. All of those things are possible. This right here was something we did for Layard in ISE 2020. The background flower, that's purely graphics. That's not a rendered video. That's built inside Ventuz. So if I had the proper parameters unlocked, I could change the color, I could change the camera view. I can show you all of that here in a second. And then the rest of it, you can see it's pulling the time from my computer down in the lower left corner. It's also pulling the location as to where we currently are, Binghamton, what the date is. And then the rest of it is basically showing some broadcast stuff of what we do, how we use things, and I'll show some of these other videos later here and ways to do it. We also do, like we talked about, we can do extended reality, we can do augmented reality, we can help push even things for virtual reality through our system. The graphics output can be as large or as small as you want. We recently just did an installation for Google with what was the world, at the time, is supposedly the world's widest Sony Crystal LED screen. So that was kind of cool to go in and play with that. The other things that are really kind of cool is when you get into a particle engine, which is really where people go with graphics, right? Real-time graphics, they're like, oh yeah, I can bring in a video and play it. I can composite over the top of it. But what if I need real-time particle systems or graphics like this flower in the background? So we'll jump out here. I'm going to open up another project real quick. This is the only real part is these projects are kind of spread out all over the place. So to give you an example, if we bring in this flower, this is the flower, and this is, it's all node-based programming. So this is how we build this flower out. Now, it's also not only node-based program, but we have layers, right? So like Photoshop, we can have 2D layers, we can have 3D layers, we can get rid of things. So you can see right there, if I get rid of the little dots, just by turning this layer off, I can get rid of the world, which is the flower, and just leave the dots. and then that sort of thing. I could go in and play with colors. I'm going to show you a real quick example. If I were to close this scene and say, don't save, we all know what real-time graphics is for. So if I wanted to put in something like a cube, I can simply drop in a cube. You can see that I have a cube right here. So if I highlight this node, and this is how real-time graphics works, right? I could play with the size of the cube in the X and the Y. I could play with the scale of the cube or that sort of thing. But I really want to be able to work on this scene. So maybe I add something in front of that cube like an access node. So now, not only can I scale that access up and have the cube in front of me, I can actually deal with rotation of the cube to show you it's a 3D object, right? But simple, and people might find this kind of cool. If I go and put in something as simple as, say, a touch, let's go here, touch orbit, I can grab a, why am I not seeing it? Am I blind today? There it is right there. If I throw this in and I put this in front of, say, access, now I can come down in here and I can, just by clicking my mouse and dragging, my mouse is having some issues, but I can drag this around and look at it in real time, right? This is what you see is what you get kind of thing. So if I was doing that, the other thing I could do is I could, let's say, open up something like this, go to my desktop. Maybe I've already got a substance downloaded that I like. I can grab that substance. Let's go for the Rubik's Cube. Oops. Let's do it. No, it's my mouse. So if I do the trackpad, I can grab that straight from my downloads folder and drop it in here as a substance. Is a material that I'm assigning to this 3D object. And now you can see I have that substance already fully applied to my 3D object. I can do all kinds of crazy things to it. Yes. If you look down here, yep, you can. Yeah, we can drop stuff out. Like, let's say we wanted to, I don't know what all these do off the top of my head, but we could delete that. That's always a bad one to delete, but you can play with it. You can modify it. So if you find a substance you like, but it's not quite what you want to do, or a material, you can assign it, and then you can actually go in and edit it in here, as opposed to having to take that material back into some other project, modify it, and bring it back in. So to give you an example of how crazy we can get with this, if I do something like, let's say, take a geometry importer. So I'm going to import some 3D geometry. I'll click on that. It will ask me what file. If I go download, I downloaded a Blender project. So you can see I pulled in this dome. We've got all this information. Don't really see the dome at the moment, right? Because I've got to find it in the scene. Let's go here. Hey, look, there's my dome. But I want to be able to control that better, so I can add an access node in front of my scene again, right? Now in that access node, I can actually go in here and say, I want to deal with that on my scaling factor to get it closer. I want to bring that dome down, maybe in the Y. Well, that's a little too close, so we can actually scale it back just a bit. Now, the substance that's on that dome looks particularly weird, right? Kind of crazy. One of the interesting things is when you're working in real-time graphics, I can easily go into graphics and skip parts of my render path. So I just turn that substance off. I don't like that substance, right? I could do it on all of them if I wanted to. So now we've got a plain white dome. I could put the touch orbit again and we could rotate around this 360 degrees however we wanted. But let's say I like most of these materials, but I don't like the one that was there. I could go back into my menu. I could grab something that's different. Let's just grab this crazy one. I can immediately drag that into my project. And now you can see that I've added a completely different material on top of a Blender project. And this is the way your project would look in Blender. It keeps your structure, right? It keeps your layers, keeps your substances assigned with those layers, all of those kind of things. Again, I could turn this one off. turn that one back on. So one of the things I like about it is I'm easily able to throw a bunch of substances in there and turn them on, turn them off for a producer or someone I might be showing this content to before we actually just send this project to the render machine. It's not even a render machine. It's render as in it's the machine that's going to display it on the end device, not a machine as in it's going to take 17 hours to render out one piece of content. But I can easily show, oh, well, you don't like that one? What about this piece of, oh yeah, we like that. Okay, well, I'll go ahead and remove that one from my project because I don't need it anymore. Now, there is one downfall to Ventuz, and we're working on it. And this is the first thing people point out when they play with it. Sadly, Ventuz does not have an undo. And it's because of the structure that was originally chosen in 2004 when it was created. When you're working with real-time graphics, you're making a massive amount of changes. So you have to undo. If you think about it, your undo could not only affect the last change you made, but 10 rows in the past. It's basically someone explains it like take a bucket of sand and a bucket of rice, pour them together. Now try and sort out the rice, right? How long would that take you to do? So there are ways to do it. Scene iterations, lots of saves, save as, that kind of thing. So you can go back. There's even an auto save feature that you can set how many iterations it will save as, and then it will start over. So there are ways that we deal with all of these kind of things. I'm going to stop this project for a moment, and I'm going to go into a general Ventuz presentation. And this will show you a couple of things. So no more playing with substances. Oops, I opened it twice, so it's going to get mad at me. So there's a couple of things. Ventuz designers, this is the system we use to build our screens, and we'll see this here in a second. Yeah, you don't need two. You only need one. All right, so if we go to, let's go to general presentation. Let's go to this one. Now, I'm going to go through this. So if we put this into presentation main, so you can see there in each project, I can have a bunch of different scenes that I can choose from. I can open up scenes, and we'll open up and play with those in a second. This is a pretty large scene. You see it there. You might have even seen that it was loading some C# scripts that are doing specific things in the project. If I start this, so kind of an intro into this general presentation. So if you're thinking of like a presentation, either an interactive screen or at a display, or this could have been playing, say, on the buildings out there in between their actual rendered shows. Now I have a fully interactive presentation, right? I don't have to go from point A to point B. I can go to point A to point F, back to B, however I want. So if I want to learn about Ventuz, I can click, and then I can guide myself through it. So obviously we call Ventuz software for creators because that's exactly what it's for. And it's data-driven real-time motion graphics. As I showed you, those data links that I showed you earlier that were either arrays or populated from a spreadsheet, that could be live information coming from a Formula One race car, right? We could be receiving the data that the engineering team is also receiving and visually present that however we want to. If we talk a little bit about, here's a quick show reel that just shows some stuff that we've done. Obviously, in real-time graphics, everybody's got massive images, things that are changing, interactions. One of the neatest things we're doing right now too is we realize that Ventuz isn't really well known. I don't know how many people in this room have even heard of it before. I know Dan has. I know Jeffrey has. We are implementing Notch to be able to be usable in Ventuz as well. And the reason being, there's a lot of people out there who know how to use Notch. But Notch doesn't do the data-driven side of things the way that we do. So people like to create things in Notch and then bring them in here and be able to use them. The company itself, it was founded in 2004, just to give you an idea, in Dubai by a couple of really smart guys who are broadcast graphics and events industries. As I said, we have a very large backbone in the broadcast side, and I'll show you some things as to what that means here in a bit. The first public launch of Ventuz was used for the Microsoft Xbox European launch and was incredibly successful when they saw what we were able to do and achieve. And again, in less than 3 years, many agencies had a lot of interest: Porsche, Volkswagen, Adidas, Microsoft, more. We do a lot of game shows. Who Wants to Be a Millionaire? We do a lot of stuff for Fox Sports. We do stuff with National Geographic. We are based in Hamburg, Germany, with developers kind of all over the world. We have an office in New York, but that's me in Minnesota, so that's kind of weird. We have an office. We have an office in Kitchener, Ontario, with a couple people there, and then we have a small office in Beijing and Shanghai. Let's talk about, again, if I want to go, I can go to anything. Remember, it's a non-linear presentation. So if I want to go to solutions, I've got this nice little, right? And it tells me all about different, what are the different areas that Ventuz is used in? Augmented reality. You're seeing all this videos, right? We do lots of augmented reality stuff. I don't have the audio playing because it's kind of obnoxious. In studio broadcasts, we can do that. Presentation and event stuff. So you can see he's walking back and forth. He's able to do touch screen, all this stuff. And the nice thing about it is, as we do these shows, if they needed to make a change, like they didn't like the text that was displayed on that phone, we could just go and type in new text. It's just 3D modeled, rendered with assets and materials and substances on top of it. Exhibition stands, game shows, of course, like I mentioned. We can do high-end presentations. I'm getting to a specific one because it relates to the other reason that we're all here. We can do presentations and events, of course. We can also do very large high-end projection mapping. Now, this is a very nice finished presentation, right? But at any point in time, I can actually come up here and grab this and move it wherever I want on the screen, right? So in a media server world, you would either have had to have like an XY panel and widget, or you would have had to keyframe this move however you wanted to. Now notice I can do whatever I want with it, whenever I want with it. So we are able to do warping and blending on our outputs. There is a configuration tool that allows you to make group things however you want, whether it's a video wall or LED wall or blend and array, a line of projectors, all of those kind of things. So you can see there, that was in Hungary, that was using Ventuz to create real-time particles. A lot of that stuff you're seeing is all real-time generative particle type effects, especially something like that right there. So you can do a mix of real-time with rendered videos, however you want to deal with these sort of things. Let's see what else we have here. Right, staging shows. Here's the live medal count for an Olympics games kind of thing. So you can put what country's in the top. And of course, if these change over time, it'll change with it. I'll jump a little ways forward into this so you kind of get a better idea of what is happening. Let's go to say there. So all of that stuff could be either a person entering, oh, it's no longer Canada in spot 2, it's now, you know, USA or whatever. You could change that. Or it could just be, I'm receiving a feed that's coming from some website somewhere that's giving me full-on information. So you can do some really interesting. OuterNet is something Dan asked about. He's talked about this before. He was asking me questions about it. It's a very, very large venue in London that is using Ventuz to drive a whole bunch of displays in really creative ways. You can kind of see here. They never know on a day-to-day basis what the show will be like or what they'll be presenting in there. So we can do a lot of really fun stuff. Like I said, you see there a fashion show or a projection display presentation or a room with interactivity. So all of that is driven by the Ventuz side of things. Pier 57 in New York is another big Ventuz project where there is a show that runs day to day, but they also use it as a special event location. They don't have high-end technicians either. So for the special event, they have an array of drop-down menus they can go to choose. This is what the background image is. They know how to upload a logo from a client, or if they need something like that, they can choose it. They can choose where it goes, picture in picture. The speed with which it processes, one of my counterparts, Justin Roy, who's kind of like a savant when it comes to widget and that sort of thing, he made an API that is referencing the Major League Baseball API. And he literally called me one afternoon and he goes, here, log into my machine remotely. And I did. I'm watching his screen. And he's got all this baseball statistics. And I'm like, I don't really understand what I'm seeing. He goes, turn on your TV, turn it this channel. I do. It's this game. He's like, Next pitch will be a strike. Next pitch was a strike. And then a couple times like that. And he's like, next thing, the guy's going to hit a double. No way. Hits a double. The API is faster than the actual broadcast delay that exists. So it's kind of like we were seeing the future. And of course, I told him, I was like, we should take this to Vegas, but I don't know if we can get bets in that quickly. But so I mean, that's telling you a huge amount of thing of how quickly we can display something faster than a broad set, right? We can't have the delays if we're in real-time graphics. Nobody wants that. It needs to be as active and as quick as possible. If we talk about, just real quickly, just to give you an idea of how Ventuz works, this is the way, not just slightly different, but we have Ventuz Designer. That's the software I was showing you before. This is where you would design all of your scenes. You basically then take that scene or project and you upload that to your runtime, which is your rendering machine, right? So then you can launch a bunch of machines at the same time with the same project. They all work in that kind of thing. So we also have, this is a little video that it just kind of explains about what Ventuz Designer is. Again, ideas rendered in real time. So what do you need? Do you need control of color? Do you need to be able to multiply, darken? Can you bring in Photoshop files and keep the structure? All of these things are possible. And you see it immediately. It's kind of like your previous thing that you were talking about with lighting consoles and this and that. It's really impressive when you get into bigger projects. Now, if you've built your scene and you want to control it, you might need something like Ventuz Director. This is more of a broadcast feature set, but it does work in live entertainment. You are then able to templatize your project and bring in those templates to Director so that you could control them however you need, whatever you need. You can see here he's laying out a timeline-based situation, and we need to adapt to on-air graphics. So what am I sending to air? I'm sending this player, this name, or the scoreboard changes, all of those things just like that in real time. I can quickly use my assets that are there to build a scene and bring that scene to air or to a live interactive feature set. And then, of course, lastly, we have the runtime. The runtime is a license that sits on a machine that's connected to your displays. It is your rendering device at the end. One of the nice things about Ventuz is if the software is built properly, it just runs. We have projects that are 5, 6 years old that are still running, and all they do is go in every morning and launch all the machines. You can see there he's setting up a video wall in the configuration output. He just started all the machines into the same project. That project spans across all of the screens and is fully interactive and touch. Everything is, we can do cluster rendering across huge canvases. So yeah, everything is able to be controlled. The Google Bay view that I talked about is 3 separate Director instances running a large video wall, a smaller video wall upstairs, and then all of the monitors for all of their rooms to say what's going on in the displays in front of each room. And it all starts with the touch of one button. You can launch the whole day's lineup. The lineup is fed into every day. They edit an Excel spreadsheet in this case to say what's coming up. It'll follow all of those kind of devices and whatever else you need to be. Of course, I won't go into, we can talk about it, but I won't really go into license models. Here's a quick view of kind of how it works. So you'd have your graphic access assets, your live video or external data come into Designer. Designer would create the Ventuz scene. You could use the Director to control the scene and then push that information out to runtime. Runtime responds appropriately. Or you could just use a presenter and runtime. So once you're done with, that's the other nice part about it. Once you're done designing your scene, and you can just have a machine that's connected to your end devices, and it can just run. You don't need to have Designer connected unless you're going to make changes or edits on the fly or anything like that. So we use a lot of these in permanent installations because we can set it up, walk away, run it over and over and over again with no problems, no instances whatsoever. If we need input control, we can handle touch data, live data, video inputs, remoting APIs, and then of course Ventuz Director to control it. The runtime is for playing. If we need outputs, we have physical outputs. We can do serial digital interfaces. We can do NDI outputs and inputs for information. We can render to disk. So one of the things that people really like about that is in the Designer window, if I make something that's really cool and I like it, I can render straight from that designer window like a previs and send that video off to my client to say, do you like this? Is this cool? Does it work? It's very easy. We can also handle render streams. I'll skip the licensing model. If any of you guys have any information, we can talk about that since we're limited on time. Feel free to see me afterwards. But we look at the Ventuz engine with all of these components where I can, of course, it's image-based lighting. We can do resolution-independent playouts, node-based programming. We can handle unpredictable content. We use almost many codecs in existence, including Notch LC, all of those kind of things. A streamlined workflow. Again, like I said, if you're working with someone who's dealing with something in Blender and you're working back and forth, sometimes it's a pain in the butt. But if they can just take their Blender project and bring it straight into Ventuz, and then the two of you, he wants to add lighting in Ventuz, you can work together while he's still working on it as well. So we can do, we don't have a live link to Blender yet. We will hopefully soon. We have a live link, of course, to Cinema 4D, to Unreal Engine. All of those are in existence at the moment. Photoshop, one of the big ones that people like is you can bring in a Photoshop file and it will keep your layer structure. So you don't have to always go back to another machine and edit that and re-import it as a JPEG or anything like that. So now let's get into some of the fun stuff, and I will show you a couple of clips here. I'm going to close this again. I really should consolidate all of these into one project, but then that project would be huge. To give you an example, that full project you just seen, does anybody have an idea of how large they think it should be? Or how big do you think that project we just saw would be? It's 2 gigs. So the other point of real-time graphics is it's generated on the fly. So you don't have these huge rendered videos. You don't have 7 terabytes, God forbid, of content. Now you can get up there when you bring in 4K videos that are also playing in the background that you're then playing with. But with a real-time just rendered graphics. So now we're going to have some fun and talk about like where as real-time graphics are going. How many people seen the majority of the displays out there at the Luma Festival, right? You saw some instances where they did some pretty cool type effects, pre-rendered effects. Well, if I wanted to do some of those, I could simply come in. Let's open up the ISE show. Wow, my eyesight's getting really bad. Oh, sorry. I know, right? I'm trying to avoid it. It is time. All right. So perfect example here. My boss may hate me for this, but he'll survive. I'll bring this up and I'll put this in full screen. So the image here, of course, you got the Ventuz logo in the background. That is my boss, the director of global sales for Ventuz. It's actually green screen. He's filmed in a studio in green screen. We keyed him out. We put him in front of this lake. And if you notice, Ventuz is doing something that a lot of media servers don't even have the potential to do. If you see the reflection, what we're actually able to do in real time is take the rendering of Mike. We basically render it to something we call an off-screen target. And then we call that target back and apply it to a different plane or texture apparatus. The cool thing about the reflection is you can choose how dense of a reflection do you want. Do you want a full resolution? Do you want half resolution? Do you want quarter resolution? So this is down at about half resolution, and it's why he kind of still looks blurry, and it works with the effect that we're trying to show here. This project has a number of scenes we can show. I could leave this scene open another one if I wanted to. Of course, there you're starting to eat into GPU resources, which we want to be careful about. So I will let me close that first project, and then I'll show you something that people are actually usually find pretty interesting. If I open, I think it's in miscellaneous, and I open this, and I go full screen. Pretty impressive space graphics. I didn't make this, but if I do say so myself, that's all real-time generative. That's a particle system that is real-time generated. So what's amazing about this is this same system right here that you're seeing on this HD screen, we took this file into Google and we put it on a screen that was 4 UHD wide, and because it's real-time generated particles, it just expands to fit. I didn't have to re-render anything. I didn't have to waste any time scaling it or doing anything to that effect. To show you some ideas of what it is, If you look up here, it is nothing more than a light and a particle system. Now, of course, it's a very complex particle system, but inside each particle system, I can go in and look at different aspects of what I want to maybe control. So if we wanted to do noise, let's see if that actually, particle systems themselves only control specific things. So we could change a gradient. This might not actually change anything. There's a little color change to the stars in there. We can go here to sprites. We can change, you can see right there, my laptop is like, what are you doing? But we can increase the size of particles. I kicked a mover in there, which is kind of interesting. I'll show that in a second. Let's just delete that. But it's multiple particle systems that are all in line with each other, which makes it really kind of cool. So animation wise, you can see right there, I'm starting to affect and move. If I wanted to, let's say, make that 7, you can see that jumped forward. So you can play with it and colors and all of that kind of cool. We can do, I don't want to save that. We can do really fancy stuff like, let's go to this one. We can take 3D objects. We can create something like this on the fly that's pretty cool. Again, just particles and particles following paths. And this could be, again, a touch orbit for direction, or it could follow someone. Like when you walked by, it could follow you, and then someone else walked by the other way, it could follow you back, however you want to have the advantage. And again, this is a couple of different particle systems. We could come into gradients and change the colors if we wanted to. You can see that they're changing over time. We could dictate a different gradient, maybe put something like that on. You can see that these outer arms just turned color, right? That's what I love about this, is how quickly you can be like, I don't like that. Let's change that. I'll just use the rainbow one again. So you can get as crazy or as simple as you need. We can get into some really interesting interactive type particle systems. Let's go with, is it that one? No, this one. So you can see here, now my laptop might choke on this. So this could be fully interactive touchscreen type device. You change something in the particle system, you'll change, a little bit about everything that's happening. You can, of course, turn off lights. We can look at, and every option has input options and output options. So you can see here's where I do my hierarchy. Here's all my layer stuff. So if I wanted to turn something off, I can turn the lighting off to show the whole world, right? I can turn the lighting on. If I wanted to block an entire render path, I can block it from any point. So you can see here how everything darkens as soon as I block that out. So if I'm trying to track down something, it's very easy for me to go through and go, oh, that wasn't it. Oh, that wasn't it. I think here, if you take that won't do anything, but you do fog, and now just have your little ball left. Bring that back. You can see that it adapts very, very quickly. And then here, when we start to look into stuff, is where we do our content or our interactions, right? So we've got basically the particle system connected to a touch translation, because this is meant for a touch screen. You've got it controlling the access and then applying an effect in that. I will real quickly just show you how easy you can build something up that's kind of interesting. So bear with me. If we do a new scene, let's go ahead and let's create an access node. Access is always a key node to have. Let's create a particle system, just to throw that in there. Okay, my particle system starts off as nothing, so I need to add modules. At this point, I'm going to add a grid, and I'm going to add, obviously, that is my emitter. I need something to actually render it on. I'm going to render it as a mesh. Let's add one more access node in front of everything so I can control this separately. Oops. Come on. All right, trackpad it is. Put that there. Now in this access node, let's rotate. Let's go 4 points on the rotation. Let's let's start playing with our particle system now. If we just look at the inputs, let's change the count from 4 to 20 and 20. Now let's spread those, because right now they're all on top of each other. Let's go here to 18. 18. We want to see this a little bit better, so let's do that. Let's see here. There we go. Let's do that. Right? Now I can go into my mesh. I could change the bevel radius to, let's say, let's do 1.5. Now you can see that they're individual squares, right? So I could play with those, but that's not very exciting. Let's add a texture, and we'll stick the texture in between our grid and our mesh. So you can kind of see we've influenced it right there. But what happens if we take the texture, which is currently controlling color and alpha, and we want to actually control, say, position, and let's control the Y position. So we got position. Let's go global Y. Now we can come down here and let's bring that down a little bit. Let's bring that up a little ways. Now you can see if I deal with this, I can do some really cool effects, right? Just by moving this around. Well, what happens if I want that to move just continuously? I can very easily either go up into the logic and add something like a mover, or right there in the notion of the particle system, I can click over here. There's a little squiggly line you might not be able to see. And that will create any one of these type of movers that I want. In this case, I'm going to go linear. I'll do the Y as well, linear. Now I bring those into my project and I can edit them. So maybe I want to go, let's say -1, and I want to do it over a speed of 5 seconds. And then let's go to this one. Let's do a minimum of -1 and add a speed of, let's say, 30 seconds. It still is kind of jittery and I don't like it. It's not my favorite thing in the world. It doesn't look that great. So what if I go back to my particle system and change out my texture? So maybe I want to go to a general texture like this. That looks way cooler, right? You got a nice little wave going on. So now we can even do something as quick as, let's say, maybe we want to make that a little less. We want to expand it so that it fills the screen. So we would just come up here and do more cubes, space them out more, right? That and that. Let's go back to my original access node. Let's bring it down. So maybe we make a floor out of it. And then what we could do is we could just take this array and copy it down and have another particle system. In this one, let's say we want to, let's see, where do I want to go with this? Let's flip that 180. And then let's make a ceiling, right? And then we could copy it down again if we wanted to. Find the particle system, go into the node here, and let's say we want to transform that. What do we want to do? Well, let's see if we can make this work. Let's do that and stick it out and put a wall out there. We could obviously do this on the other side, and you immediately have, however you want. Then, of course, don't forget, we could instantly go back to, let's go desktop materials. We could come in and find some crazy material, say this sci-fi one, drop it in front of any one of these particle systems. And you can see up here now we've got some red. Let's copy that and put it on, oops. Let's actually move that up there onto that floor space. So you can very quickly composite a scene and do ultimately whatever you want with that scene. You can then animate the scene. I won't go in. The animation is time consuming and takes quite a bit, but it is possible to do all kinds of really neat and unique animations. So you can see how quickly I can develop something. And the best part about it is I could do this in After Effects, right? But then I've always got to highlight a section of it, wait for it to kind of render quickly, and then play it back. Here, I'm just controlling it in real time. At the end, I just take my project and send it off to someone else. If I want to play with, let's see, Glare Productions. Let's do this one. No, where's the dragon? I know it's in here. There we go. So I can take a 3D object and apply effects to that 3D object. Right? So this is a Blender model of a dragon. We changed out the substance material to be kind of a jade, and then we burst it into particles every once in a while. You could set that particle burst of the dragon up to a keyboard press if you wanted to, or you could have a camera monitor the room. So depending on the occupancy of the room, when the camera was able to detect more than 100 people in the room, it could do the explosion and start the show. All of those feature sets are possible as to kind of what you want to do in terms of what your ultimate goal is. So other things just to show you, of course, as I mentioned, we can do, we talked about that flower earlier being data-driven. Let's see, I got to figure out where that one is. I think it is, nope, it's in this one. So if I open that flower, which you can see right there, there again is the thing for it. Now in this one, I have parameters that are unlocked. So you're gonna have to bear with me because this is gonna get small screen for everybody. But if we do that, if we do that, and we'll bring it back here in a second, but then I open up web interface, I go to the local address of my computer, I can now control that flower. So if we really wanted to, we could, let's bring this, I'll do this a different way. Oh, they're duplicated, so I'm kind of screwed in that regards. You can see here, I can control the color, I can control the alpha, I can control instantly whether the flower is blurred or not blurred. So you can kind of see right there, we've got a bit of non-blur. I can go back here and I could say, turn the blur on. And now notice that the flower is blurred out. So whatever parameters I want, I can unlock them to different levels. I can unlock them to scene data. I can unlock them to different hierarchies of however I want to manipulate them. So maybe the color is just going to be impacted by the lighting guy, right? Maybe the video wall, I don't want to deal with color. I'm just going to put up pretty cool particles and let him deal with it. I could do that. I could send that section to be controlled by lighting and I'll deal with the rest of it. So many, many different options. And that is the benefit of real-time graphics. You don't have to waste time coming up with an idea and then rendering it out and showing it to a client. You can show them on the fly. The problem is it also unlocks Pandora's box that you then sit there 12 hours longer and go through every possible, what if it's green? Well, what if it's this color, right? So we end up doing a lot of that as well. I think it's this one. This is kind of a cool project. This will be the last thing I'll show, and then we'll take questions. This is kind of a cool, you can see this is a lot of C# type stuff. Oh, this one doesn't seem like it's going to want to work today. This project I need a workstation for, but it generates the information that is displayed based on what the GPU is reading out to the system. So it has all these bar graphs and charts and that kind of thing. So in that case, I want to show one last video that I talked about on-air graphics. This is a really good example of just don't think of this as a broadcast product, even though the video that I'll show here, hopefully it's not too loud. So this is all done in Ventuz.
Beautiful night for baseball.
The throw, and he's out.
This rivalry, one of the best in sports.
So picture those contents as being other things that are playing on your building, or you need graphics on top of an interactive display. I was happy to see that the Horizons display is the only one that's using actually real-time generative content. Everything else is all pre-rendered. And sadly, to me, even the pre-rendered scenes in between the actual shows is all pre-rendered, but it's like effects, just pre-rendered effects. It'd be so much more interesting if it was slightly different every time or controllable or entertaining in any way, shape, or form. As opposed to, oh, well, we'll watch this 5-minute loop again of the same old ads and the same old content in the background. They could definitely do some stuff. So, for example, the arcade game one, that could be actually interactive than just 2D flat projection on a plane. So this is where you start to jump off the rails of like, oh, we're doing a show. How do we make that show even more entertaining, more engaging, and a better fit for your end audience? Products like Ventuz, Notch, Unreal, of course, but anyone who wants to run a live show on Unreal is absolutely crazy. Probably the other thing that we should talk about, and Jeffrey's aware of this, Ventuz, as you've seen, it's a very non-linear based format. Coming from Cirque du Soleil, there's no way I would run a Cirque show with just Ventuz. There's no way. We took account of that. We're aware of it. We made our first integration where Ventuz now works in media server. The particular media server at this point is called Vertex by IOversal. Much like if any of you have ever incorporated a notch scene into any other media server. Ventuz now works that way with media servers. We have a discussion with Jeffrey at some point about putting in 7 cents. We have a discussion with Connor and Harry back up in Austria for Pixara. We're looking at other media servers to integrate it into, because while there are other machines out there that do real-time graphics, there are no other machines out there that do real-time graphics, especially and able to handle data the way that Ventuz is able to handle that data and put it out however you want. So with that being said, I think I'm close to my time. Questions? If you want any information, I should tell all of you, especially the students that are interested, if you go to ventuz.com, there's what's called the Community Edition. It's a completely free edition. You'll get the same piece of software designer that you saw. It does need to be, you need to be connected to the web to use it. You need to be online to use it. But there's a very small watermark, and the limitation resolution-wise on Community Edition is 4K, which is astounding to me. And the only other thing is you can only do 500 nodes, 500 primary nodes. Now that may seem like a lot, but when you start to build a really, really complex scene, you use 500 nodes very, very quickly. So I also have my cards with me if anybody wants contact information. Ventuz is making a push into the US market. It's not that we haven't been here. It's just that people don't know we're the secret sauce for a lot of things. For example, the Quince Imaging, all the esports, League of Legends, it's Ventuz that's handling all of the data from the game engine itself. So we know this person had, was this accurate or sent this spell this many times. We can do all of that data and present it however we want. Ventuz was also part of the virtual fan thing that Dan was talking about, which was very interesting. The part Dan didn't mention is hearing stories from those guys about, there were a lot of fans, but you also had to someone curate those fans, because you can't have the guy mooning the television. So each person had a screen, if I'm not remember, that they could watch. It was like 50 or 60 individual fan sets. And if that person got too rowdy, they would just kick them out of the room. And there was another person sitting next to him doing another 60 people. And there was some Ventuz side of that. If I'm not mistaken, I think I can say it. You slap me later if I'm wrong, but the Carolina Theater Project will be a Ventuz project. So we also are, we're just releasing 6.12, which has the notch integration. We will have a version 7, hopefully by ISE. Sadly, I can't tell you too much about it, but I can tell you that it will do some game-changing things in terms of some things we've discussed in these classes about what we always have to rely on to make things work will not necessarily have to be relied on any longer. So pretty cool. Does anybody have any questions? Yeah, Mark.
So I understand it's you can take data in and visualize it. Can you spit data out for like tracking purposes?
Yes, so we work with Blacktrax, OptiTrax, Stipe. We can work with almost any camera tracking system. So stage precision.
So you take a node, put it in there, have it move, and send that XYZ out. Whatever.
Yeah. One more thing I should probably show you is, let me look this up real quick. Just give me 1 second. It is a YouTube video. A lot of people are all like, oh, everything you do, you have to do in Unreal, right? If it involves a 3D world, it should be done in Unreal. Let's see, where's this one? I'm going to mute my computer because this is in German, and it won't make any sense to most of you. So even the subtitles are in German. The ad is not in German. So there's something in Germany held every year. It's called Wacken World. It's a metal fest. Obviously in 2020 and 2021, they went completely virtual. So Ventuz was used to create the entire 3D world. She's talking to Gizmo, one of the XR artists. Now XR is not a disguise term. People seem to think that that's a disguise-based product. It is not. It is the idea of extended reality. It's exactly what Dan said. It's basically set extensions behind someone making a presentation. So when this says XR artist, it doesn't mean he only works in disguise. It just means he's very good at creating 3D worlds and placing people and things inside that world. So this entire concert, everything you see here was done in Ventuz. So all of that, you can even see there's the Ventuz designer window right there. And he'll show you all of his camera movement and tracking. He can move around this entire 3D world in real time however he wants. And that can be sent to the broadcast camera on an NDI out or whatever you want to do and integrated, or it can be sent straight to the internet. You can then green screen a bands that were filmed in the studios directly onto stages. He even shows a cow here in a minute that's like a head-banging cow that they created, right? So all of these things are possible. We chose to, yes, we can work with Unreal Engine, but if you want to, you can also do these things just in Ventuz without any additional requirements or whatsoever. So very cool. It's big in, it's one of those things that's big in Europe. A lot of people in Europe, especially Asia right now, they're big into Ventuz, and we're like, all right, well, let's go to America and see what happens. Yeah, John. We can do spout. Yeah, we can output in a multitude of different ways. Of course, we have, we can always do input cards and that sort of thing. With Ventuz 7, we'll unleash a whole lot more options for outputs and that sort of stuff. So we're very excited here on what is coming down the pipe, so to speak. Yes. Right. Yeah. Right. It's a slightly different world because remember, After Effects is a very timeline-based editing program, right? This is not that. You can get there, but the timeline that's in Ventuz is not intuitive in any way, shape, or form. So if you're used to After Effects, your best bet is then to use After Effects, but then again, you're rendering a baked-in video. So at the end of the day, you're stuck with that video. And we've all been on sites where it's the stupidest thing, but they want to change it. And luckily, as Kirsten mentioned yesterday, we've gone away from, somewhat gone away from MP4s, and we've gone to image sequences. So I only have to replace this big of this big. But I don't know how many people in here have done a lot of video rendering, but inevitably you'll be doing a very large render and get about 16 hours in and it will crash and you have to start over. So I'm a big fan of the shows that I've done with the system for real-time graphics. I'm a big fan. Just to give you a quick idea of like the thing you were talking about where you guys had to build this whole thing up for the playlist and that sort of stuff. If you wanted to do something like that in Ventuz, I will go to a specific project real quick. So in Ventuz folder, and you get to projects, each project automatically will create all of these folders. So anything you put will be stored in these folders. So for example, if I go to the data folder and I look at that playlist that we were watching, this is all it is. All I have to do is put in the name of the scene that I want to come next, how long the duration is in seconds for that scene to play, how long before it goes to the next scene. And in this case, we had a blur on or off type movement. So we could have made just a bunch of different playlists, just like you see here in the folder. And they could choose which playlist they want. If they wanted to edit one of those playlists, they could make a special event playlist, populate it with whatever scenes they want, and then bring it to air very, very quickly. So all of those things are built and exist inside. It is a very, it's kind of an overwhelming product when you first open it up. It's different. One thing I should show you, this is something I think, and I'd love to hear from you, but I think Ventuz is the, what? I'm late on time? Oh, okay, one sec. I think this is the only, I think Ventuz is the only one that does this, but I want to show you how interesting it is because this is a great way to learn in the community edition. Let's say I just open up any scene. It doesn't really matter. I'll open up a mic reflect. Let's actually close that new scene. Oh my gosh. If I put down, let's say, an access node, and I don't really know what an access node does, I can go over that node and I can highlight and click F1. Not only can I look it up in the manual, but every node has an interactive example that will open another scene that will tell you everything of what that access node does and all the input features of what that access node can do. So this is a really great learning tool when you're like, what the hell does that node do? And when you start to get into, let's say we get into nodes real quick. Let's go here. You can see we have animation nodes, color, materials, interaction. There's all our interaction nodes. When you get into animation, we have a whole bunch of animation nodes. So for example, someone's working in Blender, they send me a GLTF file with animation. I can bring that file directly into Ventuz, rig that animation to a mover so that animation will constantly go. I could rig that animation to a button press. So we did an example at a training where we took a Phoenix that was fully rigged to fly. We made it like a quick museum exhibit where it flew in. We basically went to Google. We looked up what a Phoenix was. We grabbed the text. We put that into a text node. As the Phoenix flew in from one side, the text flew in from another. Within like 5 minutes, we had what you could use in a museum exhibit, and people would be like, this is amazing. So there we go. Jeffrey tells me that's time, so thank you guys very, very much.